Hi, everyone. It's Brett Swallow here for AREC 173. So we're into our last week of lectures today. So this is the lecture for the week of November 30th to December 4th. And it's going to focus on the Module 6 discussion about social choices in technology and science. And we're focusing on information communication technologies. So I'm going to share my screen and get going. What I want to get you to get out of this lecture, this quite short lecture, is the awareness of some new uses of information and communication technology and what we call big data in agriculture and food. And I'm going to give you some vocabulary that may or may not be familiar with you that I've kind of put into the last slide, but that some of which I'll be using as I go along the way. And then think about the social challenges that are rising with these new uses of these technologies and this data, and how some of these challenges are being addressed. My former colleague, Andy Jarvis, who works for the International Center for Tropical Agriculture in Cali, Colombia, has talked about these 4 recent changes in information and communication technologies affecting agriculture. The first one is cell phones. There's been an amazing expansion in availability of cell phones and cell services especially across the developing world. Farmers and others now have these increasingly smartphones, but still a lot of interesting applications have developed for just using short messaging services that allow farmers to send information and to receive information from those they're interacting with. We can talk about this facilitating the last mile. So it has been notoriously hard to get information services out to millions of smallholder farmers, given that they're widely dispersed as they're working the land. So this is a way for them to cover that last mile to kind of connect with their service providers. Second thing is sensors. There has been radically reduced cost of sensors which are smart, which can update information and broadcast that information and send that information. And generally, many of those smart sensors have helped to create the Internet of Things. So that are sensors which are located on hardware which sense information and transmit that information. The third recent change is what we talk about as big data analytics. So the ability to process large amounts of information using new techniques like machine learning and artificial intelligence, providing information that is more useful and more readily available. These new ways of looking at data have allowed us to see patterns in large amounts of data that we were not able to see before with traditional statistical techniques. A fourth thing is about kind of the greater availability of data, and a big aspect of that has been the greater availability of remotely sensed data. Much of that is remotely sensed from satellites, but also has been remotely sensed from aircraft or can be sensed from drones. And this data is more fit for purpose for agriculture, according to Andy, much higher resolution. So the pixel size is much smaller than it used to be, and more frequent and more available. I'm going to give you 3 slides about applications of big data and this information communication technology in agriculture and food, which are becoming increasingly prevalent in the last few years. The first set of applications is on farm, especially thinking about precision agriculture, so more precise use of inputs. This is where we use technology to improve input efficiency and at the same time gather data for future decision support. So decision support is the computer management of data to help us make decisions. In this case, is decision support about inputs. There are sensors and GPS, global positioning system units, mounted on machines as part of that Internet of Machines, combined with computer models to monitor and assess production conditions and address and adjust inputs. That might be the seeds, fertilizer, or water, to optimize production, minimize waste, and to be alert to possible problems. So this has the potential to radically improve efficiency of production systems, and we've seen the importance of improvement in efficiency to meet the EAT Landsat goals, for example. This requires new source types of hardware, including new equipment. In Canadian agriculture, that is, we often think about variable rate technology that allows a farmer to adjust, say, the quantity of fertilizer that they're putting on different parts of a field, sensors on harvesting equipment that monitor yield and relate that yield to particular parts of the field, guidance technology like GPS technology and cameras, which are part of kind of self-driving reduces farmer fatigue and allows more precise application of inputs. Remote sensing, which is used to monitor and assess field conditions from satellite data, and other types of sensors. The applications include monitoring yield, mapping fields, like you see this irrigation field, which has been mapped for different soil levels of soil health. Scouting crops, especially using drones, which farmers can see into the middle of their fields without getting into the field. Input adjustments, like this variable rate technology, weather tracking and forecasting, so farmers can think about when to harvest and when to plant. Irrigation management, thinking about the quantities of water to apply to optimize the use of water. And financial management. We'll talk about that in a minute. So here's some images of drones, which are used in agriculture, the GPS set of satellites, which place us on the planet that we use routinely in everything we do, and the type of equipment that farmers have on their tractors now. So that's on precision agriculture. Precision agriculture is very big here in Alberta. Another set of applications is beyond production into the rest of the value chain. It was evident during the COVID outbreak that everyone in the value chain were able to shift much more quickly to digital platforms of exchange. And as they did so, had the bonus of improved knowledge base for targeting clients. So there was a need to quickly shift food from one way that it was getting to consumers to other ways. So shift from the retail and institutional sectors into home sectors. All of the digital technology allowed that to happen quite rapidly. And with surprising resilience. Financial services have become really penetrated much more just in the last couple of years in Africa because of information communication technologies. Along the way, mobile phone companies like Safaricom in Kenya have linked with banks to greatly expand access to financial services. That includes transactions like e-transfer that we use here in Canada now, finally. Small savings accounts, which either the mobile phone companies provide or that the banks provide, or micro loans. And then another new innovation is weather indexed insurance, which is linking weather data to provide insurance products so that we don't need agents to go out and assess crop damage. We can just relate changes in weather to levels of crop. And if we get poor weather conditions, we know we've had a poor crop, and it triggers payments. A third area in the value chain is on food safety. So a whole range of sensors is being developed with and used within food processing facilities. They could be used within stores. There's lots of research on their use in food packaging to help ensure food safety, and which would also have the benefit of reducing food waste. So this company, SICK, has sensors in meat processing facilities and says that it has allowed it to go to a failure rate that's essentially zero, that it catches every bit of contaminated food and sets it aside. A third area of application big data in agriculture and food is public good applications. So one of these things are transparency. So this might be, for example, what is the incident of food safety scares? That can be, with better data about that can be made available to us so we can better have more trust or faith in our food system. Performance dashboards, so opening public data quickly to the outside world allows citizens to hold the public agencies accountable. Second one might be monitoring and measuring environmental effects of food and agriculture. So things like pesticide residuals and farm fertilizer runoff. Farmers may or may not like this. They may feel that data about this will mean that they will be regulated more tightly. So that's an interesting area of tension between farmers' rights to gather data to help them make their production decisions. But if someone else gathers that data and avails it, they may say, you are applying too much fertilizer, or you're putting it say you're putting it in a place which we have identified as a wetland. So this might be a source of tension. As I said, the last mile communication from farmer advisory services. And a fourth area is research. We have examples here at the University of Alberta where sensors that measure individual consumption of food and water is linked with genetics to select animals to breed for greater feed efficiency and lower greenhouse gases per unit of output. We see that research can be used to generate new products which are useful for a whole variety of uses, and often those involve public data, combining public data with private data. And another area of research which is exciting is the possibility of citizen science or crowdsourcing of knowledge, where you have digital platforms where individual farmers can upload their information and provide, and each farmer then become a researcher themselves. And we have an example here that I observed in Ethiopia. There's a researcher there who's facing to the side of us with his backpack on, working with farmers in fields in Ethiopia, where each farmer has undertaken an experiment with 3 different varieties of crops, and they're assessing those crops. Their assessment is uploaded from thousands of farmers to a central database, and then researchers do analysis of that data for quickly understanding where different seeds are appropriate or different varieties of crop are appropriate. So I'm going to stop there. I think that's enough for one mini lecture, and then come back with more discussion about the kind of issues in application of these technologies. So I'm going to stop sharing.